So today we got a ton of material to cover because there's a lot of really interesting things we're going to learn about JavaScript that really start to make it so that we can build applications that do things. Okay. The first thing we're going to take a look at is JavaScript dates. Okay. I'm going to clear this console. We create a date by saying new date, right? And new date is going to return a date object to us that we can store in a variable and use and get information about, right? So I can say var my date equals new date, right? And so now my date is a date object, right? And the toString of that, right? If we do my date dot, it has all these functions, all these methods, and we're going to go over these one by one, just so we know how to use and manipulate this object. The other thing you can do, you'll notice that when I say my date, or when I say new date, it is setting a date to the time the date object is created, right? So in this first example, it created at 4:04 essentially Eastern time. This one was created at 4:04:16 and stored in my date. If we look at my date again, right, it is still 4:04:16, even though that time has moved on, and now it is 4:04:54. We've been talking about this for about 45 seconds. So storing a date object in a variable preserves the date to the time the object was created. Okay? So does everyone understand that, like, when we create a date object, we're saying give me a date, like a valid date that we can do math on, we can compare it to we can store in a database, we can do all of these things to dates. When we create the date object with new date, it is setting it to that time that is created by default when we pass no arguments in. Now, if we wanted to set this to a specific date, right, we wanted to say, hey, new date, what we can pass in as an argument here is a string, of options, right? So we can say, 02/13/1984, right? And so now the date object is February 13, 1984. Okay. We could also do it in a different type of format. We can do 1984 02/13, right? And you'll notice this is doing something kind of wonky. It's saying February 12th, 1984, because we have just crossed over. This is the time zone, right? So we, here in America, I'm in Eastern time, right, is 5 hours apart from GMT. Okay, so when the math starts to happen for this new date object, sometimes it gets a little confused if you don't provide a time. And so, from where we are right now at 4 o'clock, it thinks that it's really, like in this example here, when it created this date object, it created it at midnight, but this one was created at 1900. We can continue to put in, right, hour, minute, second, right? I can say 12, right? And now it is February 13 at noon, right? So when you're creating dates and you just want it to be a specific date, make sure that you always pass in a time component, because sometimes the date object will go backwards in time, even if you think, hey, give me February 13th. Well, it gave you February 12th at 9 o'clock at night, which is pretty weird, right? Because the default is 00:00:00, and then like GMT -0, right? That's like the default. What else can we do with dates, right? This takes, we can do 1984. If we put in just 1984, right? It's going to give us, same problem, right? It's giving us December 31st, 1983 at 1900 hours. So this date object is dependent on the time zone of the client computer that it's running on, right? If I was to change my time in here to be 5 o'clock, and I said new date, the date object would return 5 o'clock. This is a really useful way if you're building a website that is intended to be used by anyone on the internet, right? The date object will let us get the user's local time on their computer. It is not safe and reliable to rely upon, right? Because I can say, hey, we have a special that we're doing a sale on our website, and it kicks off at 4 o'clock on October 6th. Well, if this is the only place that we're checking this, any user on the planet can go in there and say, well, I'm just going to make my time 4 o'clock on October 6th, and now I get access to this special, right? Like ticket sales. If you're building Ticketmaster, things like that, where you want the tickets to go on sale at a specific time, right? you want to use the date object in JavaScript on client side to show the user, like, hey, this is what your time is, but you want to verify that on the server. And we'll show off how to do that later. So var, some date equals new date. Let's do 1984 0213 8 a.m. Right? So some date is now my birthday. Right? This is my birthday object and it exists. Now we have a whole bunch of functions. Right? When we type some date like this, what's really running behind the scenes is the someDate.toString function. Right? That output that we see on our console is the toString function. But we have a whole bunch of other functions that we can run on this toDate, right? We can say someDate.getYear, right? And it's going to give us 84. If I need the full year, I could do getFullYear, 1984. Okay. I can also say getMonth, and it's going to tell us 1. Does anyone have an idea why it says 1? For February.
Because it starts at 0.
Yeah.
So February would be 1.
For whatever reason, in JavaScript, the get month is a 0 index thing. And I believe the reason they implement it this way is if you can imagine you've got an array of months, our months equals, it's like January, February, right, March, right? It's so that if you ever wanted to get the full name, right, if you had some kind of array like this, you could just say our months someDate.getMonth, right? It's letting us use this in a data model to get nice and pleasant names and things. That was probably why it was originally implemented. There are better ways to do this now, but I think in order to preserve backwards compatibility, they very rarely will make changes that can break large amounts of code. The date object has been a part of JavaScript since the 90s, right? People have relied on this working this way for 30 plus years at this point. Okay, right? We can also do someDate.getDay, right? And it's going to tell us 1. Why does it tell us 1? Does anyone know why it's telling us 1? If the date is this, why does getDay tell us 1?
Is it getting the day as in Monday?
Exactly right. Monday is 1, Sunday is 0, Tuesday is 2, right? And it's the same reason that getMonth, right? It expects to be used in an array. It expects to be used as a value where you're going to output things. We can also do someday.getDate, right? And that's going to give us the actual date that we're looking for here. So there is a getDay, which tells us day of the week, getDate, which tells us the actual date in the month. We also have someDate.getHours, right? So in this case, 8, right? This is an actual number being passed back, so we could do math on this if we wanted to. We could say, someDate.getHours plus, what is 5 hours plus that, right? It's 1300, right? 1 o'clock. The date object by default, get very comfortable as a software engineer working with 24-hour time zones, right? Because whenever we do math, it's very easy for our computer to understand, like, hey, 12 plus 5 is actually 17, right? That's simple math for the computer to do. It's up to us as developers to say, I want to display this in a way that is friendly to our users. Maybe I need to subtract, if it's over 12 hours, subtract 12, right? So we could say someDate.getHours, right, minus 12, right? So it's 1 plus, and then we can say PM, right? The string PM. So now it's going to say 1 PM, which is the correct thing, right? And if I did 6, right, 2 PM. Let's do 12, right, 8 PM. Any questions? We also have, as I'm sure you'd imagine, some date.get minutes, right? This is also an integer value, right? So, you know, the time here is 8 o'clock, 0 minutes, 0 seconds. So this is going to return the integer 0, the number 0. We also have get seconds, right? 0. Okay. This is one that you're going to come across really frequently as a software developer, right? Some date dot get time, right? And what get time is going to return is the number of microseconds since 1970. That was when time started. It's called Unix epoch time, Unix epoch time, EPOCH, 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 however you want to pronounce it. This is a common time that we started counting time from, right? So a Unix computer, rather than caring about the date object and caring about all this stuff, simply said we just need to count seconds up from, you know, when we launched this computer, so 1970. So every computer has been based off of Unix epoch time, where they're just adding seconds from 1970, right? So, and in this case, JavaScript is doing something crazy where they're actually using milliseconds, right? So 1,000 times seconds, right? So if we did some date dot get time minus 1,000, or excuse me, divided by 1,000, okay, that is the number of seconds between February 13, 1984 and 1970, right? And if we look at you know, new date dot get time divided by 1,000, right? This is the current number of seconds since 1970. Okay, and so we can do this minus some date dot get time divided by 1,000, right? I'll put this in here too. Perfect. So that is the difference in time between when I was born and today, right? So we could do this value divided by 60. Okay, so that's minutes divided by 60. That's minutes in an hour divided by 24. So that's how many days? If oh, I gotta put all this in here, right? Order of operations and stuff, right? 13,750 days since I was born to today. Is everyone following along? How we're able to use math to calculate differences between dates. This is how this exact type of format, this exact type of structure, is how programmers have been calculating dates and calculating differences between dates since 1970. Right? I've been doing this for 20-something plus years. Whenever I need to work with times, and so even when we move into databases, and even when we're working on nice modern languages like JavaScript, behind the scenes, all these dates are calculated as differences in time between seconds. Right? So even when we have the date object, new date dot get, you know, full, let's just do toString, right? This string representation is the computer being nice to us and calculating all these things behind the scenes as seconds with simple math operations to tell us where we are today. So we have all these get functions, right? Each one of them, right? If we just clear this out, so we have some date, right? Some date is February 13, 1984. If I wanted to say what day of the week will February 13, 2022 be, I can do some date dot set year, and we'll just put this to 2022. Okay, and so now we see some date. My birthday is going to be on a Sunday this year. That's pretty exciting. I get the day off. Very, very good. You'll also notice that some date dot set year is returning that same time code that it has in that provides us with get time, right? So this is microseconds since January 1st, 1970. Any questions? Any questions about set year, right? We can also do some date dot set month, right? I can make it, I could say, hey, I want the second month, which is March, right? So now if we look at some date, now it's March 13th. That is also a Sunday. That's pretty cool. And we could say some date that set month 3, right? That's April. That's gonna be a Wednesday. Everyone tracking? We can also set date, right? Some day dot set date. We'll do 22, right? And so now it's Friday, April 22nd, 2022. So we can use this date object to build dates, calculate distances between dates, like how many seconds have elapsed. We can create countdown timers using this type of date. It's a very powerful object built in to the language. And we're going to use it both on the client side for being nice and displaying things to our users, and we're going to use it on the server side when we're actually writing code to verify data integrity, to when a user is created, maybe we need to create a new date to say, hey, you created this user account at 4/19/2021, right? So that we can store that type of record. We will use the date object by just saying new date, right, and doing something with it. Go ahead.
Just so I understand the terminology correct, some date is an object that you created.
Some date is a variable that contains an instance of an object I created, right? And we're going to talk about instancing when we get into learning about classes and object-oriented programming. But essentially, right, date is a function, right? Right, it's a function. And when I call the word new in front of it, it's saying, give me a copy, give me an instance of this function that belongs, it's returning it, right? So whatever when we create a variable called some date, we're saying, I'm going to have this variable, and I want you to put an instance of the date function as an object for me to use.
So could some date a variable then as well, just a defined variable?
Some date is a variable.
Okay.
What it contains right? So some date right now is a variable that I just created again. It's a brand new variable. I just declared it and assigned it at the same time. But some date as a variable currently has a date in it, but I can come in here and say some date equals pizza, right? Now some date, the variable, just has a string in it, and the word is pizza. So what a variable contains is always going to be different. It's going to be whatever you just stored in there. And the name of the word doesn't matter. Like the only thing that we would encourage you to do is pick good variable names that make it very clear what is going to go in it, right? I picked some date in here, but now it says pizza. That is misleading. And if you're reading this code expecting this to be some kind of date, and you said, some date dot get year, right? That's not a function of a string. It is a function of a date, a method of a date. And does that make sense? Cool. Any other questions about dates? Anything on here we didn't cover? Nope. All right. Now on to the fun stuff. We're going to talk about conditionals. We've been kind of hinting at this. We've been showing off a few examples of this. But this is, in my opinion, what makes us capable of being programmers in the first place, right? I can write a whole bunch of lines of code that print things out. We can echo things to the screen. We can create dates. We can create variables. But if we cannot control the flow of a program, we can't make choices and say, if something is this, do this. If something is something else, do something else. This is what makes programming possible. Okay? Conditional operations is the backbone of any kind of programming that you will do for the entirety of your career. We are being paid not just to create variables, not just to print things to the page. We are being paid to take some kind of input and make decisions with that. And we do that with conditional statements. JavaScript has a few. We're going to look at the two that we're going to use most of the time. Some other programming languages have a few others, right? And there's no right or wrong answer for why why you would choose one syntax over another. There are a few like stylistic reasons perhaps, but if you can understand that the concept of conditional statements in JavaScript, that understanding will translate over perfectly to other languages like PHP, C++, Python, Ruby. Right? All of these languages all have this kind of structure, right, in some form or fashion. So let's take a look at some of these statements here. So we're going to use an if block, right? An if is a block. And so just like with everything else, all of our if blocks will have curly brackets, right? So we're saying if something is true, right, do what is in here, right? All of the code inside this block will execute if and only if this evaluates to true. This is the concept, we talked about it a couple days ago. This is called Boolean logic, right? We're saying true or false. And we can chain together with the syntax we're going to go over today statements that will evaluate to either true or false, right? There's no in between. It can't be true and false. It's true or false. Okay? So, how would we structure an if block, right? So, let's go back to our console. Clear? Right? So, I'm going to make a variable called or check this. And we're going to currently set it to true, right? So, check this is currently true. I'm going to make a function here, and I'm going to say run an if block, right? And I'm going to pass check this to it. And so inside my function, and I'm just doing this for repeatability, I'm going to write an if block, and I'm going to say if check this, right? Then it will console.log true. Okay. So if I do run an if block and I call this and I say check this, right? It's printing out the word true. If I change check this to false, okay, and I run check this, it prints nothing. Because none of the lines of code in here have evaluated, right? It skips over this entire block from curly bracket to curly bracket if it's false. Now, that is the core, like if you learned nothing else, with an if block by itself, you could build an entire computer, right? You could build an operating system. This is how fundamental this is to programming. Now, we have some other niceties that let us write more complex, right? So, a good example of this, let's rewrite our function. So, I could come in here, in my check this, and I could say, if not check this, right? So, the exclamation point is the Boolean symbol for not, right? Not means the opposite of this, right? So, not false would be true, right? Not true would be false. It just flops the value. So if we say not check this with an exclamation point, and I write this, I can say, oh, I got too excited and hit enter. Ooh, come on, click. Up. Right. If not check this, console.log, it is false. Right? And I run that. So now run an if block. Right? If I pass in check this, it will say it is false. It skipped over this one because it's not true. Check this is false right now, right? Check this is false. But when it gets to this line of code, it says if not check this, right? If not false, which turns it to true, this entire, anything inside the parentheses of an if block is evaluated as a single statement, right? Saying, check all these conditions. If not check this, console.log, this is false. So that's what printed. If we change this back to true, check this equals true, right? And we run it again. Now it prints out true and does not print out this is false. Okay? Everyone tracking. Other thing, JavaScript, this is where things get kind of wonky sometimes, right? So because check this is true, there are a whole bunch of values that are in JavaScript interpret as true or false, right? So if I said 1, right, that's the same as true. And so if I run check this, it's going to print out true for us. If I change check this to 0, what do we think is going to happen?
It's going to say false, or it'll be false.
Because 0 evaluates to false. Now, we were looking at this yesterday when we were playing with the index of function, right? If I made this -1 and I run this, it's going to print true because -1 is a value, right? JavaScript treats anything that is a value, for the most part, as a true thing, right? So I could put in check this equals Eric, right? Run that, and it's going to print out true because Eric is a value. True, yes. If I wanted to check the specific value, to say, right? If check this equals true, I can actually make it equals, and we'll talk about that here in a minute. This will not run, and this will not run. Okay. So we get no return, we get no print, because we are using Boolean operators here, Boolean logic, to say if check this does not exactly equal the value of true, make it false, right? And so now if we did run an if block, and let's just pass in some stuff instead of changing our check this variable all the time. I will say 1, right? It's returning nothing. It does nothing again because 1, even though we know 1 is true, does not equal true, right? 1 equals true, right? That's true. But as soon as we put a third equal sign in here, it's saying check to see if this is true and make sure that they are the exact same value type. That is false. Equals will get you out of a lot of trouble when you're expecting to check for a specific value and you want to get away from like things that are kind of true, right? Generally, 99% of the time, you're going to write your code like this, where you're just going to say, hey, I'm just checking to see if something is true or not, right? Like 150, right? 50 equals true, right? So if 50, console.log, yes, right? So the if block is checking true values all the time, right? So we have also learned that the exclamation point, right? If I put not 50, it's false. But I can also chain these together if I wanted to be really crazy and say not true, not 50, which is true again, right? So not true is false. Not true is true. Not true is false. All right, you can chain all these together to your heart's content. You should never write code like this, right? But it's a really good way if you wanted to force it to be true, or if you wanted to force it to be a specific type, right? So like, not 1, for example, is false. But if I wanted to turn 1 into a true value, I could say not 1, which gives us true out of this. Whole bunch of like behind the scenes geeky nerd stuff where you'll sometimes see this used as tricks or like clever little hacks, just to be aware that like this is possible. We can put together any number of Boolean operators to get any type of true or false result that we want. Okay. So we learned about, when we were taking a look at our function here, let's see if I can find it. Perfect. So this is just using if blocks, right? And let's take out this part. So we'll say if check this console.log true. Then we have a completely separate if block that says if not true, do something else. We have some syntactics means like the syntax of this just makes us gives us some options to make things look prettier. We can combine this into a single if-else block by putting the word else after the final curly bracket. So this is now saying if this condition is true, run these lines of code. Otherwise, run these lines of code. So the problem is, just to be aware of this, right? Like most of the time you're just checking whether something is or isn't true, right? But in this specific case, right, if we'd said check this equals, Eric, right? If check this is Eric, that's true. But every other version of check this will now display it is false. So if we want to check the specific version of what we're looking for here in a variable, using an else block, we'll say in any other condition where this does not match, run this code, right? So if I was to run this now, I can run an if block, and we put in, true, right? It's going to print out false. If I put in Eric, it's going to print out true. If I put in false, it's going to turn out false. If I put in Eric with a capital E, false. We are evaluating the truth that the variable we're passing to this function is exactly ERIC. Every single other condition will spit out it is false. Any questions? That's if combined with else. Just like this. And you put the else directly after the closing curly bracket of your if block. And then you have it has its own curly brackets, right? This is a second block. This is an else block. If we wanted to check multiple conditions, right? We have that as an option as well, syntactically, right? We can say if check this equals Eric, and then we say or, right? Else if check this equals Eric with a capital E. Oh, I hit enter too soon. Right? It gets its own block, and then the else goes below that, right? Console.log true for Eric, right? So we're saying if it is Eric lowercase, do this. Otherwise, if it's Eric with an uppercase E, do this. Otherwise, in every other condition, do else. Right? So if I do this now, run an if block, and we say Eric, we're going to get true. If we change this to E, Eric, true for Eric. If we change it to ERIC, right, it is false. So we can chain these as many times as we want, right? You can only ever have one if block. You can only ever have one else block, but you can have as many else if blocks as you want, right? So I can come in here and say, right in here, I'll say else if check this equals Eric. Console.log true for Eric. Right? So we can chain as many of these types of statements together as we want in an if. Once we start an if block gives us all this extra flexibility to say otherwise check this, otherwise check that, and then finally if none of those conditions apply, put it in, do this. And so if we do run if block right now, we get true for Eric. And if I put a space after that, that's going to be false now, right? Because it's looking for an exact match. Equals looks for an exact match. The cool thing is, right, none of these, right, the only thing that matters when you choose to use an if block is the if block itself. You don't have to use else if blocks. You don't even have to use an else block, right? The if block is the important part. But once you're in an if block, you have some flexibility to choose where do you go next. What are the other things you're going to look at? Any questions about if or else if or else? Now, do I want to... yeah, okay, we're here anyway. All right, so we've already talked about the not operator, right? Exclamation point is the not operator. And I'm sure you guys have heard me say this a bunch of times. I have a bad habit in CSS where I'll say not important, right? Not important. When in CSS, it does not mean not, but I've just been programming for so long, when I see an exclamation point, to me that immediately screams out not. In CSS, when you use exclamation point important, it really means like, this is really important. It doesn't mean that it's not important, but I have a really bad habit of when I'm describing CSS rules, I just say, the name of this operator to me is the not operator. And so that's what I say. For that exact reason, we explored that we can use the not operator in front of any value and have it be the opposite Boolean value of whatever that expression evaluated to. Okay? The not operator directly changes the value from, if it's true, it goes to false. If it's false, it goes to true. Now, another operator that is extremely important in Boolean logic is the AND operator, which is denoted as 2 ampersands. Ampersand is Shift 7 on your keyboard. So if we say true and true, right, that is true. If we say true and false, that is false. The AND operator looks at 2 expressions and verifies that they both show up as true. Both of them have to be true. If we say false and false, what do we think that it will be? What does false and false evaluate to?
True.
False.
Oh, I was thinking too negative.
Yeah. So as soon as when you've got a chain like this, you're on the right path, and I'm glad you're thinking mentally like that. The ampersand, the and operator, this thing in a Boolean structure, is looking kind of from left to right, and it's saying, is this true? And the answer is no. So it stops evaluating. It says, nope, false. The and operator is looking for both being true, both sides of the equation being true. Right? If we did true and true, that's true. But if we do true and false, now the whole thing is false. We can chain multiple Boolean logic, Boolean operators together to make complex checks. We can say if, what do we have here? Check this, what is that? It's Eric. If we do if check this equals Eric and, what's today's date? New date dot get date equals 6, right? Because today is the 6th of, what are we in? November? October? Whatever today is. Today's the 6th, right? It's saying, is check this Eric and is the date today the 6th? And the answer is yes. If any one of these is false, right? We can check to see if check this is Eric and today is the 7th, right? Now that's false. Or if we did it the other way, right? 6 is good. Or if we say if check this equals Eric with an uppercase, right? It's false. Ampersand is looking for truth on both sides of its ampersand. And you can have as many of these as you want. True and true and true and true, right? Like you can chain these forever. If one of these was false, the whole thing evaluates to false. Everyone tracking? So we will generally write if blocks that say if, check this equals Eric and, some other condition, right? Some other thing that has to be true, right? We're checking usually multiple things inside a single if block. Most of the time. We're chaining them together to make sure they are all correct with ampersands, the and sign in Boolean logic. Now there's another interesting one, and that is the or operator, right? So and is this, or is two pipes. Pipe is shift, and then the key that's right above your enter key, right? It's the straight up and down arrows. What or does is really interesting. It says if either side is true, the whole thing is true, right? So if I do true or false, it's true. If I do false or true, false, it's still true because one of those was true. If I do false or false, the whole thing is false. Everyone following along? Or is how we would generally chain together more complex checks. We would say like, if check this, let's just type this all in one. If check this equals Eric, or, true and true, right? Right, the whole thing is true. But if one of these was wrong, right, we make this Eric, right, it's still true, even though if we had put an and sign here, it would have been false, right, because one condition was out of place. So we will generally use the or operator when we're checking things like if you are an administrator or you are a regular user and you're allowed to view this page, right? So the administrator is like, you got superpowers. You can see everything. But if you're not an administrator, are you a logged in user that has permission to see this page, right? And you would generally write something like this, right? If, user, user.type equals admin, or user dot is logged in, and user dot can view, right? Like that. That'll be what our code will look like. And then it'll be the actual code that says, let them see the page, right? So what we're doing here, right? None of these are real fun. This is an example code. right? We're saying if you're an admin, let him in. Or if you're logged in and you're allowed to view the page, then you can see the page. Or you might do the opposite. You might say if user.is logged in, right? If not user is logged in, right? They can't see the page, right? We can write code like this. So you can check the correctness, you can check the truthfulness of something, or you can check the falseness of something. Because if the user is not logged in, right? If this is false, then putting a not sign in front of it is going to turn it into true. So they cannot see the page if this is here, right? And we would generally write code that looks like this, right? It would say something like, page.redirect, to the login page. All right, this would be what our structure would be like. We would have one simple if block at the very top of the page that says, I don't need to run any other code if you're not logged in. So if you're not logged in, I'm just going to stop execution right here and redirect you to a login page. Cool. Yep. So other things that show up as kind of false values in JavaScript, this is JavaScript specific now, right? So if we do not, so we do if, let's do, we have to check this, right? Let's rewrite our function. So we can show off all of these things. So this is our function here. I'm gonna change all of this to, I'll do this. So I'm gonna say if check this, we're just checking for the truthfulness of this now, right? We're just gonna say, is this true or not? Console.log this is true, right? Okay, so that's our function now. So run an if block, right? We know that if we put 1 in here, it's true. We know that we put true in here, it's true. If we put in the special JavaScript thing, NaN, that shows up as false. Not a number is false. Okay. Also, undefined is false. And null, right? You guys remember null, which means like there is no value here? Null is also false. What about an empty string? Empty strings show up as false. When you have an empty string, it is false. If you put a space in here, now it is not an empty string, it is true. These are the kind of things when we're writing JavaScript, both on the client side and on the back-end side, that we're going to use to our advantage to make it easier for us to write good code, right? If you can imagine, we have this input here, right? ID age, right? If we say document dot get element by ID, what do we call it? Age, right? Dot value, right? It currently equals an empty string. So if I was to say if document dot get element by ID age dot value, right? Console dot log. Just right? Console dot log the thing, right? Otherwise, else we want to document dot get element by ID age dot style dot background color equals red, right? So if there's a value in there, we want to just print it out to our console. Otherwise, turn the background color red. So this turn it to red. Now, if we put something in here, reload our page. If we put something in here, as soon as I put any value in this box, it's now going to print it out to our console and not change the background color to red. Because of that nice feature where, I deleted my cool function. Is that the right one? Yeah, perfect. Run an if block, right? Because empty string shows up as false. Now you have to be very careful with if blocks when you're doing math, right? Because 0 is a false value. So if you're doing mathematical operations that could have a value that equals 0, you have to intentionally check to see if 0 is an allowed value. Otherwise, if you were just expecting to be like age plus 10, right? Age is an HTML input. So if I did 37 plus 10, right? We're good. But if my value was negative 10 to begin with, plus 10, we're at 0. That still might be a valid result. But if you were checking with if negative 10 plus 10, right, that would fail. Never fires. So if you are checking and you want to see if negative 10, if 0 is a valid value here for you, then you have to simply say equals 0. Right? Now it fires. Or you can say equals 0, right? You could use an OR block here, right? You can say if, you know, I'll show. I got an idea. We'll do cool number equals num equals negative 10. Right? So if we were to do if num plus 10 equals 0, or num console.log never fires, right? Well, this will fire because we fixed it. So what this is saying, because we're using the OR block, which is, hey, if there's a value in num, good. Otherwise, if number plus 10 equals 0, we know there was a value in num. Oh, excuse me. We should have written it like this. Or num plus 10. Right? Either way, one of these is going to be true, right? If num was actually, 15 in this case, right? So 15 plus 10 is not going to equal 0, but num plus, 15 plus 10 is a number. This is a valid yes, a valid truth. So you have to sometimes, with JavaScript specifically, and with some other programming language as well, check to make sure when you're working with numbers that valid values aren't being excluded. This is a common type of bug that can sneak into your program accidentally. Like you can imagine, accounting software where you're like, tracking invoices and accounts payable and accounts receivable. And if you're checking to make sure, like, hey, somebody put in a value in here, well, sometimes 0 is a valid value. If this up here said 0, for example, right? Let's see, document.getElementById age.value, right? Right now, it's the string value of 0, so that will always be true, right? So we can do not, right? That will, right? This is always true. But if we were to have already processed this with parse int, 0 is now showing up as false, because that's actually a number. So you have to be very careful when you're dealing with user input and when you're dealing with numbers, because sometimes it can bite you in the butt. Any questions? All right, it is 4:51. We're gonna take a short break, come back at like 5:05, and we'll keep going. We got a lot of cool stuff to do today. See you guys in a bit. All right, cool. So there's one last thing that we want to look at here with the if blocks. It's a shorthand version of it's a shorthand control expression called a ternary operator. Ternary operator, T-E-R-N-A-R-Y. You're going to see this used pretty frequently in JavaScript as well as in other programming languages. This is a pretty common type of control structure that follows the same sort of logic but is a little less sophisticated. And what a ternary operator lets us do is like kind of condense a simple if else check into a single line of code. Let me pull up a browser window, right? And so the format of a ternary operator is, some value, then it has a question mark, and then the true value, right? So console.log true, followed by a colon, and the false option, false. Okay. So some value is not defined. Let's some value equals false, right? So if we run this line of code, some value is false, it's going to say question mark, and then it's going to check, right? Since some value is false, it's going to go right into this line of code, and we'll print out false. If we make some value true, right? Some value equals true, right? and we run that same line of code, some value is true, right? You will see this used pretty often in assignments, in variable assignments, right? And I'll give you a good example, right? We might say var user, right? Let's actually make var my name equals Eric, right? So there's a variable called my name and it equals Eric. Let's imagine we're writing a user object, right? Using the object literal format. And what we do in here, right? We say username, right? Colon. If there is a value in the my name variable, we want to put that here. Otherwise, we want to put the word guessed, right? So we would say my name question mark. We put in my name if it's true, and guessed if it's false, right? All in one line of code. And so now if we take a look at user, right? It has username Eric. If I was to make my name equal to something false, right, like an empty string, and we run that same, right, we're creating this object, right? Now user has guessed in the answer. We will often use the ternary operator for exactly this type of scenario, where we're saying, I'm creating this big variable full of a bunch of stuff, and if something is set to something, use it, otherwise set it to some default, right? Like, think of this as like letting us set default values. Ternaries also can be chained, right? So we can say something like, let's say, my name equals Eric, and then let's say age equals 37, right? So we could say my name equals Eric, question mark. This is going to be true, right? So this will be the true value, and we would say, okay, console.log Eric. Or, right? Colon is our or operator. And we say here, if it's not Eric, right? We want to say age, question mark. So if there's an age provided, console.log you are plus 37, age, right? Or console.log no user at all, right? You cannot have semicolons in your ternary operator. It's like one line, right? It's statements from top to bottom. It's a single expression from top to bottom. So if you when I put a semicolon in there, it broke, right? So this is kind of what we were trying to go for here, but I was breaking it up so you could follow along structurally, right? So it says my name equals Eric. That's true, so it prints out Eric, and then it's done. But if my name was not equal to Eric, or was Sally, right? My name is now Sally. It's going to say, okay, it's not Sally, but have you provided an age? And if so, right, you are 37. If age was not provided, age equals, right, make that blank. Now, it's going to go to this final condition. It says no user at all. It's generally not, I can think in 30 years, I've written maybe 15 ternary expressions that were like this kind of complicated, where I had a couple of different conditions. Generally, when because my belief is that we write code for other developers to read, this can get kind of crazy to like follow the logic through when you got a whole bunch of question marks and colons. But I will use ternaries all the freaking time when I'm doing stuff like this. A single simple ternary expression. And this part up here, right, is, imagine it's the inside the parentheses of your if block. So this can be kind of complicated, right? I can say equals Sally, right? And if we look at user now, right. Oh. Username is Sally. If we were to write this, my name equals Eric, right? That's going to be false, even though Sally is in there. And so if we look at user now, it's going to say guessed, just like we specified. Ternary operator. This is called the ternary operator, and it's question mark, colon. The thing you're evaluating goes very first, then you follow it with a question mark, then it's the true and the false. Any questions? All right, so we've been looking at if blocks, right? There is another type of control structure that is really common. It's in JavaScript, but it's also in PHP, Python, most major programming languages. Right? This is if blocks, and we know, like, let's say, let's write this name. Var age equals 37. Well, let's do name. Var my name equals Eric, right? And we'll check here. My name equals Eric, right? If I wanted to check for other people's names, right, I could say else if my name equals Sally, else if my name equals Josh, right? That's how we chain multiple if blocks together, and we say, console.log my name, right? Let's put all these in here, even though that's kind of silly, right? This can get kind of crazy. We're evaluating just the single variable, right? Each of these things that we're checking is the single value of what is my name equal. So we have a more elegant control structure, and that is called the switch block, right? And so how this works is switch is kind of unique in that it's operating on a value. It's not operating on an expression, right? So all of these take Boolean arguments, right? So my name equals Eric. And we could put in complex things where we say and, age equals 37, right? We can make complex expressions because this is trying to get a true or false. But what a switch statement lets us do, using this exact same type of structure, is we could say switch my name, right? And then it gets curly brackets all the way down, right? So this is a block. And inside the switch block, we have a special keyword called case. And what case does, it lets us put in a value. We follow the case with a colon. And then we can say, console.log hi Eric, right? It will evaluate any number of statements, right? I could do console.log hello, right? Until it gets to the special keyword break. Okay? So when it finds a match, Eric, it runs these lines of code. You can kind of imagine that this is a block of itself, right? So it's running these lines of code until it reaches the word break. But what we can do is we can chain all of these together, right? We can say case Sally, console.log, what a cool fake name, break, case Josh, console.log, hi Josh, right? Break. So we put it, it's the word case followed by the value we're trying to compare it to, and if it matches, it will run those lines of code up until it finds a break. This lets us do some kind of cool stuff with the switch statement, is that if you don't have a break, you can chain multiple values, multiple things to select together, right? So we can say case Karif, colon, then we do case Olivia, colon, case Eric with a K, and I can't do Eric again, Eric, because that would match this case. So you're not being excluded. We're in the top spot. So all three of these, if it matches any of them, will run whatever statements are here. Console.log hello students, right? Break, and it will run up until a break. So this is called like pass through or pass down. Sometimes you'll hear this referred to a bunch of different ways. But what it's doing is it's saying if Karif matches, it says great. Well, it's going to run every line of code until break. Case doesn't match, Eric doesn't match, so it ignores those. But then it gets to here and it says hello students, and then it says break. And then it stops. As soon as you get to a break, it leaves the block completely. So this whole block, it's done, right? So whatever case matches will be the one that has the lines executed until break. Now, if all else fails, a switch statement also has a default keyword that works the same way. So we could say default console.log I do not recognize you. Okay, break. So, assuming we have unexpected token function, line 106. Let's yeah, perfect. We broke our code yesterday. We were playing with the quiz, right? Properties undefined, setting lookup. No. Get rid of that too. Okay, good. So my name currently equals Eric, right? Let's take out all this other code so we can see this. Right? Save. So it says Eric, hi Eric, hello. Because it's this block running first. It's saying if my name equals Eric, it's printing out Eric. Then it's saying, let's take this one out. We'll show this off, the switch statement by itself. Right? So it gets to Eric, says hi Eric, hello, and then it's done. Right? Hi Eric, hello, and that's done. If we change my name to Olivia, right? It's going to operate on this one. It's going to say hello students, and then it'll be done. If I take out a break at any point, right? If I take out the break in Josh, it's going to run hi Josh, then it's going to run hello students, then it's going to run break. Right? So if I save this and change me to Josh, right? Hi Josh, hello students. If we put in a name in here that we don't recognize, like Eric Harrison, I do not recognize you. Do you see how a switch statement is kind of a cool structure for letting us like just check a single value and do some interesting things for it? Right? We could say things like switch my age. Right? Let's write an age thing here. Right? We'll say case 1, case 2, case 3. Oh, here, let's do this. Case 21. Console.log. Happy birthday. Enjoy a beer. Right? And then we say break. And we can say case default. Alright, excuse me, default. Console.log. You cannot drink. Right? Break. And so if we make var my age equals 21, right? I can drink. Anything else? 19. I cannot drink, right? And so if we wanted to make it so that the default is, case 21, right? We want it to be 21 and older can drink. Anyone below 21 can't, right? We could do case 1, case 2, case 3, case 4, right? On down the list. Case 5, case 6, case 7. Right, on and on. I'm going to stop typing because I think you guys can get it. Console.log. You can't drink and not drink. Break. Then we might say, case 18, case 19, case 20, console.log. You can buy lottery tickets. Right, and we're not going to break. Then we're going to say 21. Once you get to 21, it's also going to say happy birthday, enjoy a beer. Right? So if we take out our default altogether, right? If my age is 19, it's going to display you can buy lottery tickets and happy birthday, enjoy a beer. If we made my age equal, 5, right? You cannot drink. Done. Does everyone kind of understand the power of a switch statement? It lets us do some really interesting things with specific variables and specific values. It is not checking true or false things. It's not Boolean logic. It's just saying, does the value that we're switching on match whatever this case is? Cool. All right. Let's talk about functions now. We've been playing with functions. I've been just kind of using them sporadically where it makes sense. But let's take a look at the actual, let's dive deeper into what a function is and how we define them and declare them. All right. So we got our beautiful case statement there. So functions are defined as a block of code that we want to be able to call or execute later, right? So we can say function, say hello, right? And we just simply say, console.log, hi there, right? So this is a valid function declaration. It's got the function keyword followed by the name of the function. Then it has curly brackets, and at the end of that, like everything inside this block of code will be called as soon as I execute or call this function. Right? So if I say hello, right, it prints out hi there. If I say hello without parentheses, it's going to print out the source code of this function, or let us assign this function to another variable. Right? I could say var other function equals say hello. Right? Now I've made a copy of the say hello function. Say hello in the variable other function. Right? It's doing the same thing. So if you wanted to pass a function around, which we'll talk about here in a second, that would be the way you do it, right? You just don't call it. If you call it and assign it to a variable, right? Other function, right, now says undefined. Does anyone know why other function is undefined here when we just declared it right here? Go ahead, Kreef.
I'm assuming you didn't call it by using the parentheses at the end?
No, so we did call it. We called it here, but the problem is, if you remember back to our function, is that when we assign a variable, when we're saying var other function, right? Maybe it would be better as like var value new value equals say hello, right? If I look at new value, it's showing up as undefined because functions have a cool property to them, which is that they can return a value, right? So we can return, inside of a function, return hello, right? So it's going to print out hi there, and then when the function is done, it's going to return the word hello. So if I say it now, right, it still prints out hi there, but if we look at new value now, new value has the word hello in it instead of being undefined. Now it's important to note, stylistically, generally we use functions to like separate out blocks of code so that we can have a really nice word to say, hey, I'm going to call this and it's going to do some stuff. And some of the examples that we used earlier today, right, like new date dot get date, right, as an example, right? The return value of get date is 6. It's the 6th day of the month. Okay, these are two functions being chained together. We're saying, hey, I want to create a new date, and then from that new date, I want to call its get date function and return that value. There's probably a whole bunch of crazy code behind the get date function here to say, like, what is my, take this date object, figure out, like, what is the actual date that we have here behind the scenes, and let's return it. I think if we call new date dot get date, I think this is going to show, it's going to show native code. That means the code to actually run this is not JavaScript. It's inside the browser. It's probably C++ or whatever Chrome is written in, right? So when you see this, it's telling you that it's exposed a function to us, but it's doing something in the browser that we can't see. But it's working the same way. It's returning a value to us. You'll notice that if I say new date dot get date, and I put this in var date, my date equals, right? It's showing undefined here because the function did not do anything. It didn't console log anything. It's just getting the date and putting it in this and returning it to our value, right? If I put it here without, right, in the console without assigning it to a variable, it's showing us the return value of that expression. It's returning 6, as this like little arrow here means to us. It's returning 6. So generally, when you're writing code for functions and when you're building your own functions, you probably want it to do one thing only, right? So you probably would not want to mix and match some kind of outward thing and a return, right? It would not make sense to say document dot get element by ID age dot style dot background color equals blue, and also return a value. That would be kind of like mixing and matching what you're trying to do with your functions, right? You can do this. There's nothing stopping you. But a better way to do, if you said this was like make thing blue, right? Make thing blue is this function, okay? it would be far better to have this be separate functions, right? So make thing blue just sets it to blue, and maybe function get current color will return document dot get element by ID age dot style dot background color. Right? So these are like, it's important that whatever you know, when you're thinking about naming your functions, when you're thinking about creating a language that makes it descriptive of what you're trying to accomplish, it's almost always best practice to like do one thing and have that one thing be the name of your function, right? Like it might be something complicated. You're definitely going to write functions that are like, doing 15, 20 lines of code in it. It's doing a whole bunch of complicated stuff, but you want your function name to be so descriptive to say like, this is why this function is doing this. This is what it's trying to accomplish, right? Like, so now we have a make thing blue function that when we call it, it's going to make the background color blue of our input. And we also have get current color function that will return the word blue to us, right? These are, like, if you're having it do something, if you're having your function do something in the page or in the world, or when we get in the back end, store some stuff or save values, you don't generally want to mix and match those two theories, right? You don't want to say, hey, make the thing blue and console.log a bunch of stuff and return a value, unless, here's like the one exception to this, you might want to sometimes say, return true, right? So that you can check if it happened or not. Or you might want to have it return get current color, so that you can see the color that was set. Right? So it's important to start thinking structurally of functions as like, I'm going to create a language that lets me write lines of code that can be easily read and understood. So you can say get current color will return blue. Right? If we have when we're writing code in here, we want to let our functions be descriptive of what we're doing inside that code, so that it's very clear why you would want to call it what they're going to do. It's bad practice, and everyone's guilty of this. You're going to do this in your career. I've done it in my career probably 4,000 million times, right? You'll write a beautiful, simple function that does one thing, and then you'll get a feature request, and you'll be tempted to just go in and write a couple extra lines of code in that function because it's being called already. It's almost always better to write a second function if you're going to do that kind of thing. But what you choose to write, how you choose to write code is completely up to you. There's no right or wrong answer. It's just style. It's just preference. So as long as you're consistent with yourself, and as long as you're following your team's coding style guidelines or whatever standards in the company you're going to work for, you're good. So that is the anatomy of a function, right? It starts with function as the keyword, the name of the function, then parentheses, and then curly brackets. Everything inside the curly brackets will be executed when the function is called, right? And we call a function by calling it by itself with parentheses and a semicolon or whatever. Functions can also have arguments, right? So if we wanted to make this not blue, right? Let's change this now. Let's use good practices. Make thing a color, right? We want it to not always be blue, right? We can just say color. Okay. We can put in an argument in here, right? One or more arguments. We can put any number in here, right? We could say, color. We could say, if our function needs extra, like, we'll see more complicated functions later. We can put any number of arguments in here, right? Like we can put age. That's a good one, right? Like element, right? And so what we can do is we can say, hey, make thing a color. Right now we've got this hard-coded to be the ID, the element age, right? What if we said age is our default element? We can use, right? So we say if element, right? So if something is passed in this argument, okay, we're going to say document.get element. We'll just say if element. Oh no, here's what we'll do. We'll do the opposite. We'll say if no element is passed, if I did not pass an argument in here, we'll do element equals age. And then what we can do is, in the getElementById function, we'll put in the element there. And so what we're saying is, make thing a color is a function now that takes one or more arguments. The first one is a color. The second one is optional. It's an element, right? We made it optional by saying if you don't provide one, we will put in an age. Now, it's also good practice in JavaScript or in all programming languages that we need a color, right? This is supposed to set a color. We should probably make color a required thing. So what we can do is, if not color, if no color is passed, we can return false. Or we could return some error message like, you must provide a color, right? Any type of thing, right? Return, we can have multiple return statements in our code. Let's return false here, because I like that. So we're saying, if you don't provide a color, we're going to return false immediately. We're not going to execute any other lines of code. If you do provide a color, right, then it goes down to here, 105, line 105, and says, if there's no element provided, let's set the element to age. If it gets down to here, right, then we have an element, we have a color, and we can set the background color to that. And the final thing we're going to do is we're going to return getCurrentColor, right? We're going to return a value passed to us from, so here's another problem, right? getCurrentColor doesn't take any arguments. So it's still hard-coded to say age. So what we probably want to do is pass getCurrentColor our element. And then we can put element up here and element right here. So what it's going to do is make the thing a color. Right? Let's play with this right now. Because I called it right here. Perfect. So if I do make thing a color and I type in blue, I'm passing one argument. That turns blue and it returns to us the color blue now. If I put in, I could put in hex codes in here. FFCC99. Right now it's going to be like a nice light pink or something, right? Or orangey tan. Okay. If I put in an element, right? If I say header here, it's going to make our header element up here this color. Because we've passed in two arguments and we checked it with an if block. And then the cool thing that we're doing is we're saying, hey, when we get down to the bottom, if we haven't provided, let's not put in a color. Let's put nothing in here, right? It's going to return false to us. You can have multiple return statements in a function, and you'll generally use them like this, where you're saying, hey, if this condition is bad, like I don't want to execute anything else, and I want to tell whoever called me that this didn't work. So we're saying, hey, you didn't provide a color, right? Return false. We might even come in here and be extra nice to ourselves, and we might do console.error. You did not provide a color. This is required. Right? If we save our code now, we run this same line of code. We gave ourselves a nice console warning message, console error message, and it still returns false. But if we provide a color, right, pink. Now we got a pink element here. And if we provide an element, right, header, subhead, see that one. Now we get this header as pink. Or we could do any element that has an ID. So this is kind of the building blocks of all cool programming, right? Bunch of functions that have some encapsulation of code that we can put control structures in it so that we say, hey, if you provided a color, right, you can see why control structures are so important. Because they let us choose what happens inside of our block of code. So this is functions in JavaScript. You will write millions of functions over the rest of your life. The thing that is probably the most important part, and I want to really harp on this, is picking good names for your functions is probably the single, like if you're going to spend time doing anything, it should be making sure you have really good names of things. Variables and functions and objects, like pick good names. Pick names that explain what the thing is going to do. Think of a function as like, if you think back to English class, like functions are your verbs, right? These are your actions, right? You're saying do a thing, set a thing, get a thing. You're telling the computer to perform some action. So you want to make really good verbs as a part of whatever code you're writing. And that's super, super important for functions that do bits of work, right? I could just easily write a function called, I could just say var something equals make thing a color, right? So I've got a function called something now blue, right? I can name a function poorly, but it doesn't tell me what it's going to be doing, right? Make thing a color blue, right? Lets me know what is the action that will be performed when I call this function. And make thing a color is probably a really bad name already, right? Let's think of ways to improve this, right? Maybe it should be set element background color. Okay, that's clearer, right? Or maybe set background color if I don't want to type a bunch of things, right? That's probably a much cleaner and better name because it's telling you when I pass a color in, it's going to set a background color. And maybe element is not a good name for an element, right? Because what if I had actually thought I could pass in an element, right? Like document.getElement by ID header, right? That is an element. If I was to pass this in as an argument, right? What did I call it now? Save. Yeah. If I was to say set background color, and I say blue, and then I pass in as my second argument the element itself, it fails. Because it's trying to take this element, right? If we do document.getElement by ID header, it's trying to pass this in as an argument to get element by ID. We cannot do document.getElement by ID with an argument of document.getElement by ID header, right? That will give us null because getElement by ID expects a string. So maybe a better name for this argument would be element ID. We'll just change it in all these places. Element ID, element ID, element ID. Or, right now that we've got this changed, oh, I missed the spot. Element ID, element ID. Right? Maybe what would be an even better way to do this is we change this back to element, and we add an extra if block. Let's go back to element everywhere. Right? So we say if not element, set the element to age. Okay? Then below that we can say if type of element equals string. Right? If it's string, maybe we want to say element equals document.getElement by ID element. Oh, excuse me, element. So we're saying, hey, do the getElement by ID thing and assign it to element. Now we can simplify our code and just say element.style.backgroundColor equals color. And then we can pass the entirety of the element to our next function. So instead of doing this, we can just simply say element. Does that make sense to everyone what we just did? We've added an extra check, so now it can take either an ID or an element, right? So if I run this code now, make thing a color. Who's calling make thing a color anymore? Oh, this guy. So if I do set background color, and I say blue, right? It sets our default element to blue. If I do set background color pink, and I put in header, it's going to set the header to pink. If I pass in an element, document.getElement by ID, let's make it subhead, right? It worked on the other element because we've now, with if blocks, made our function more resilient. It can take a string or an element. This is kind of advanced stuff. This is the kind of things I would expect from you as a kind of a mid-level software engineer working on the job, right? Most of the time, when I would say, here's an example. When you graduate from this class, right, and you're going to work in your first job, you're going to get a task that says like, hey, write a function that will let us make an element a background color, set a background color for an element. And so you come in here and you probably write something like this to begin with, right? Perfectly valid code. Then your senior engineer is going to say like, well, what happens if I don't put a color in? And then you're going to have to think, okay, well, if there's no color provided, like if not color, right? Return false. Right? They're generally on the job going to like either give you very detailed expectations up front, like kind of how we do our homework, where it's like, do these 10 things, make sure these all work. Or when you submit your code, they're going to ask like, what happens if this, what happens if you don't put something in here? What happens if you put in a bad value? And all of those things you're going to have to then say, well, I don't know. So you can start to become a more valuable, more seasoned, more thoughtful software engineer simply by thinking through those scenarios on your own. If I said to you, make a background color function, well, you know you're going to have to take an argument of a color, and then you're going to have to take what element does this work on. You're going to have to at least have those 2 arguments. So you'll have to start thinking through, what are my edge cases? What happens if I put in something that's not a real color, right? Like, I don't know. Let's test it. Set background color blurple. Right? That's not a real color. Oh. Wait. Let's go back to this the working code. Where are we at here? Perfect. Set background color blurple. Right? Nothing changed, but maybe our function should prevent us from putting in fake colors or something. I don't know. Or what happens if I put in a hex code, let's see, FF9, right? That's valid. If I put in FF 999999, right? What is that doing? I don't know. Should we prevent that? Probably. So the entire practice of programming is not just writing code, but it's thinking through what can go wrong here. What do I have to catch? What do I have to prevent? All right, so that's the first way. This is the official, formal, old school way of writing functions, right? You say function, whatever name, parameters, and then brackets. We've also played with, this is kind of a different style. We're saying var get current color equals function element. We put a semicolon at the end. And we say return element dot style dot background color. These are exactly the same thing, just written in a different style. Exactly the same thing. And I can show that, let's say, get current color 2, right? So I've created 2 different functions, slightly with different names. So if we do get current color dot toString, right? That is the code for that function. And this is the code, I'm going to call it 1 or 2. 2. And that is the code for this one, right? You'll notice that it took out the name of the function here, because this is what's known as an anonymously defined function, right? We're saying, I'm going to create an anonymous function that has no name and assign it to the variable getCurrentColor2. We can also write functions, right? So when we're going to learn about callbacks here in a little bit, right? There are a bunch of functions like set timeout, for example. I think we looked at that on the first day. That the first function the first argument that it expects here is a function, right? So I could have passed. Let's make a function here. Let's say function alert hi, right? Alert hi. Oh wait, alert hello, right? So in the set timeout function, it expects us to pass it a function. So I could say alert hi here, and I put in 1000, right? That's 1 second. And if I save this, 1 second into the page being loaded, it alerts hello. I can also use an anonymous function right here, right? I don't have to declare an entire function. I can write in something like this. I could say function alert howdy, right? So the entirety of the function exists right here. It's not stored in a variable name. It doesn't have a name. It's just being passed to set timeout, because set timeout expects a function. This would be like this is a really anonymous function. So now it alerts howdy instead of hi. Okay. So we can write functions either anonymously, like this, doesn't have to have a name. If we want to do it anonymously, we generally will either pass it to a function, right? Like we're passing it inside of another function, or we will assign it to a variable. And we'll say like, alert howdy, right? Saying var alert howdy equals function is functionally identical to saying function alert howdy equals function, or in this syntax. These are the same. It's doing the same thing. It's creating a function. Just how do you define the name for that function? Both are good. You have to do the anonymous version, right? This version, when you're working with objects, when you're working inside of objects, right? So if I was to write a var user object, right? If I wanted to say hello, right? I have to use the anonymous version in here inside of an object. Okay. If I wanted, right? So alert hi. If I was to try and write, another way we could do this is, right, if I wanted to say hello like that, I could write a formal function outside of it, right, like say hi function. I can assign it inside of my user object by saying say hi function. Okay. This is doing the same exact thing. Stylistically, which method you choose and how you want to write your functions is completely up to you. You can use the full function alert hi. I most of the time choose, I think, this format the most frequently when I'm just writing default functions. But when I start writing more complex objects and I've got user objects and I want to have methods and things in there, then I switch over to this type of style where I say equals and then I use an anonymous function. There's no problem mixing and matching stylistically in your code, right? A function is a function. It's going to be called regardless. I just choose the best style that matches where I'm at, right, in the code. Well, let's get rid of these boys. All right, cool. Any questions with creating functions, how we use them, how we call them? We got it now? Are we pretty good? If I said to you, Olivia, please make me a function that will set a background color to blue. You could write that probably. Go ahead, Olivia.
I probably could, but it'd take me way longer than everybody else because I'm still kind of catching up.
It's supposed to take everyone longer now until it becomes muscle memory where you think in your head, I need to write a function, and you know that you're going to either type like this, function, make color blue, right? Or you're going to write it like this, var make color blue equals function, right? Like that. Both are exactly the same. And this is the start of making a function. So now what you get to write in the function is the fun part. That's where you get to write the actual lines of code to do stuff. But you should be able to, at this stage, recognize that if I'm going to make a function, I'm either going to write this line of code or I'm going to write this line of code. Those are the two ways. Cool. And here's just some terminology, right? This is pretty generic, so these types of words and these types of terms apply in all programming language. Like, so when we say the word function, it's the function declaration. It's kind of like when we say a variable declaration starts with the word var or starts with the word let. When we say function, that's a keyword that says what comes after me is going to be a function, treated as such. Then we have the name of the function, right? Then we have the arguments of the function inside the parentheses, and then we have the statements, right? And that's any lines of code in between the curly brackets. That's a block of statements. Okay. We talked about anonymous functions. We kind of talked about callback functions. Another important distinction to point out. We've kind of been talking about this on the periphery since we started learning some of this JavaScript stuff, is that function and method are interchangeable words for the most part. Technically, a method is a function that exists in an object, right? So like when I created the user say hello or user full name, Those were methods of the user object. Now, one of the little weird quirks of JavaScript is that even when we're writing code, if I say var my function equals function console.log hello, right? If we were to use the traditional terminology here, right, this is a function, right? It's a function. It stands on its own. It's not a part of an object, right? Yes? We all kind of track along with that? The problem is, JavaScript is a super weird language. And it creates a top-level object called window, and every global variable that you create in JavaScript becomes a property of the window object. So window.myFunction is the function we literally just wrote. So every function in JavaScript is a method, and every method in JavaScript is a function, right? So the terms are kind of wishy-washy in JavaScript specifically. Generally, when we talk about methods, we're referring to, a specific function that we've intentionally added to an object that we've written. But just be aware that behind the scenes, there's, method and function are perfectly, just use the one that feels natural rolling off your tongue. Nobody's going to hopefully be pedantic and be like, you used the wrong word here, right? None of that matters. Because JavaScript is a weird language. Okay? All of our variables, right? Like var my name equals Eric, right? My name is a property of the window object. My name, right? So it's dumb. It's all dumb from top to bottom. JavaScript's weird. You just have to embrace the weirdness, and that's what makes it super fun. This has been a haphazardly created programming language over the past 30 years where they just wanted to make websites more clickable, right? We wanted to be able to click buttons and have things happen. And so it just kind of evolved in this beautiful and interesting way. Go ahead, Olivia.
So before the console, how did you guys check and all that?
Alert.
Like, what was your workflow?
I would alert all the time. I would say, alert my name, right?
Oh.
What is the value of my name? It was very painful. The late 90s up until maybe 2005, 2006 was brutal. And really things started to get better. All of these consoles came out of, so Firefox at the time was competing with Internet Explorer 6. And Internet Explorer 6 had stopped all development. They were like, we won the browser war. Every computer has Internet Explorer 6. We don't need to make any changes. Mozilla had gone bankrupt as a company, but they launched the open source product Firefox based on their code base. So Firefox was a brand new, beautiful browser with all kinds of new features. They had a plugin store where you can go and just install extensions. I think they called it plugins in Firefox. And one of the guys that was working on web development was like, if I can make a plugin to make Firefox do something cool for myself, I'm going to make, I want a JavaScript console where I can write code and see what the current values of things are. So that first thing was originally called Venkman, right, named after the Ghostbusters character Peter Venkman. But that became Firebug. If you guys ever hear the term Firebug, that was the first really good JavaScript console where it had a document object model inspector like this. You can click on things and see what the current values were. It also had a built-in JavaScript console. It created the console.log, console.warn, console.error API. This was such a great tool that almost every web developer from the early thousands switched to Firefox. Like overnight. We were like, I'm not going to code in Internet Explorer. This browser sucks. We all switched to Firefox. And then we got mad because our code didn't work on Internet Explorer because Microsoft stopped developing on it. Eventually, we got to a pretty healthy place, 2012-ish, 2013-ish, where Chrome came out. Firefox is still a great browser. Microsoft started working on Internet Explorer again. Now they all have implemented this type of thing inside their browsers. So Safari has a developer console like this. It's not the same, but it works similarly. Firefox has one. Chrome has one, and they all share pretty similar features. But it was bad before, real bad. Something wouldn't work, and you'd be like, I don't know. I wrote good code. It was painful. Good question. All right, it is 6 o'clock. Let's take another break. Come back at 6:15. There's one more really cool thing I want to show off with functions before we move on. So we've been playing with the concept of, providing a named argument in here so that we have a variable that we can pass to a function and use it as a part of our code, as a part of what we're doing, to make the function actually do something useful in the world. But functions have this magical, cool capability behind the scenes that I want to just show off. Args thing. I'm going to call it args thing. So I've created a function that does not have any named parameters provided to it. But what I'm going to do is I'm going to console.log the word arguments. Okay? And so if I call args thing, and I put in Eric as an argument, the arguments being passed to this function in the 0th position is Eric. If I put a comma in here and I put in, header, right? Now there are 2 arguments, Eric and header, right? So there is an arguments function, or an arguments array that every function has by default that takes any arguments and shoves them in an array so that we can use them. Okay, so that is another way we can make things a little bit more dynamic or a little bit more flexible. So this is a great example when we were looking at, what was the example from yesterday? One of the array methods that was letting us put in any number of arguments, right? They didn't actually go through and add, argument 1. Type this in here. They're not going there saying arg1, arg2, arg3, arg4, arg5. What they're doing is they're using the arguments array to say, no matter how many arguments you put in, I'm going to grab all of them, right? And so if we were to come in here and we say the args thing now, right? It always is going to tell us, this arguments array is always going to tell us how many arguments are passed, whether or not we have used them or have put them in as a named variable, right? I can do console.log arg1, console.log arg2, right? And let's do this, right? Everything else, right? So what you will generally see when people are writing cool functions like this is that they'll provide an argument, like they'll put in a named argument like this, and then they'll say something like everything else, right? Or maybe like elements, right? So that when you call this function, you know as a programmer, hey, this is expecting at least one argument, but maybe I put in more arguments, right? And so what they will do is, instead of using elements, right, because elements is a single argument, right, is they will attach themselves to the arguments array and say, ignore the first one, right? If we look at arguments 0, for example, right? Arguments 0 here is arg1, Eric. But if we ignore this element, right? If we said, okay, let's make ourselves a loop here real quick. We haven't learned about loops super well yet. We say, hey, let's skip argument 1. So we're going to start our count from 1 instead of 0, and let's I is less than arguments dot length I plus plus, and then we'll simply say console.log extra plus arguments I. Right? So now I can have as many arguments as I want in a variable, or in a function. I can say something else, something else, right? And we can write as many as we want and let us write really cool, beautiful functions. That's the arguments option. Arguments by itself, right, is not defined outside of the scope of a function. It only exists in the function when you're writing your code. So it exists inside any function block and is specific to that function, right? If I pass nothing to arguments, args thing, arguments, console.log arguments. Arguments is going to be empty, right? It's going to say it's got a length of 0, right? So we can always check this. We can see how many arguments were provided, how many things am I going to operate on, right? It's very powerful. Any questions about that? Arguments? No? All right. Let's talk a little bit about scope and go from there. So I'm going to clear out some of this stuff. So when we're talking about scope, scope is a word in programming that means where a variable is visible to, right? So when we're working here, we say var my name equals Eric, right? This line of code is operating in the global scope. Global scope. It means this variable is available anywhere, right? So if I was to write a function called my variable checker, right? I can do in here console.log my name, right? And if I run this code in our browser, my variable checker, right? It is going to print out Eric. If I make a variable inside my variable checker, I say my other name equals Harrison, right? And then I come down here below it and I say console.log my other name, right? You will see that my other name is not defined because inside the scope of a function, any variables we declare inside of that function are only available to that function. So in the global scope, we have a variable called my name. We also have a variable called my variable checker that is a function in the global scope. And when we try to console.log a variable declared inside my variable checker, it does not exist. So think of these curly brackets. Anytime you see curly brackets like this, think of it as this is creating a scope for us, where any variable we create inside of it is not going to be visible outside of it. So a great example of that is our for blocks, right? So or if blocks, right? So if I say if true, right? We'll say var secret equals hello, right? And I can console.log secret right here. If I leave that and I say console.log secret, right? We should see. Oh, this is breaking. If we call my variable checker, we see hello, and then we see hello again because this variable was declared inside of a function. So function scope takes priority over smaller scopes than that, right? This is one of the reasons, and we're going to learn about this when we learn about ES6, is that there is a variable called, there is a way to declare variables called let that protects the scope more efficient. What's the best way to put this? So if we defined our variable with let instead of var, right? Now when we call my variable checker, you're going to see that outside the scope of this if block, secret does not exist. It's going to log that the first time, and then it's going to the next time it's going to say this variable doesn't exist here. The var keyword, which we've been learning this whole time as the way to declare variables, is the old-fashioned way to write variables in JavaScript. And the reason it's kind of old-fashioned is because what it's actually doing is whenever we put var in here, even though this is a scope of its own, any variable declared with var is hoisted. So it would have been as if you had declared this up here at the top. But when you use the let keyword to create a variable, these variables are not hoisted. They are not moved up to the top. Okay? So when we call it this way, it says Eric hello. When we declare it with var, inside of a function, or inside of an if block, it's hoisted to the top of the other scope that it's in. Now you'll notice that if I said, well, let's see. Let's show this off, right? So we're in here. If I say, okay, right, we already have a thing, right? My other name equals Harrison. If I run my variable checker, and I then check my other name, right, it's not defined. A function scope is one of the things that a variable with the var keyword will not hoist out of. And the whole reason for that was we use functions in JavaScript to create objects for ourselves. We use it as a intentional way to encapsulate and protect variables inside of our program. But all these other types of scopes, if blocks, switch blocks, things like that, are not intended to be so protected, and so the var keyword would hoist up and expose that variable to other parts of the program. So when ES6 stands for the ECMA script version 6, which is I think they're up to like, they're working on ES7 now. This is like modern JavaScript, the 6th version. We introduced a few new types of ways to declare variables to protect some of these scoping issues. Scoping refers to where a variable is defined, where it is declared the first time, and who is allowed to see it. And so global scope is anything declared at the top level. Function scope is anything declared inside of a function. And then block scope is anything declared inside of a specific block, whether it's an if block or a switch block, any of those things. Does that make sense to you? And this is going to become super crystal clear when we start learning ES6 later on in the course. We didn't want to muddy it up too much, but we're going to start using let, and we're going to start using things like const, right, for constant variables that don't change. Those are ES6 features. And when we start to use those, the scope in which those variables were declared is going to be incredibly important. Any questions with scoping? Go ahead.
So if you declare a function within a function using let,
Okay.
outside of that function, can you use that same name since it's
yes. So
okay.
Let's show this off. That's a really good one, right? So I've got a function called myVariableChecker. When I call this function, I'm going to define a new function here called someCool function, right? Oh, excuse me, function. This has to be anonymous. I don't know what I'm doing. Somefunc, right? And I could say, console.log function inside a function, right? And so, if I'm in my variable checker and I say somefunc, right? When I call my variable checker, it's going to declare this function and then call it. Right? We can show this off here. So I can say my variable checker, Good. And it called that function that we defined inside of itself. But because we defined it with let, right, somefunc does not exist outside the scope. But I could make it. I could say, let somefunc equal something cool, right? And so if I call my variable checker, right, somefunc is now defined as that function in the scope of my variable checker. But if I type somefunc in the global scope, somefunc is something cool still. But I can still call my variable checker as many times as I want. And I can also, in here, right, just to show this off, I can say console.log somefunc.toString. Okay. And if I run my variable checker, right, it's going to show us that's the source code of somefunc. And I can also check, somefunc outside is something cool. Now let also does some other cool things. If I say something here, this should throw a warning, I think. Somefunc equals something also cool. Right? Now, when you use let, it says identifier somefunc has already been declared. Right? So when it gets to line 18, let does not let us overwrite or redeclare a variable if we've already declared it in that same scope. It does let us declare, like this is in this scope. Let is protected inside whatever scope it exists in. Right? And if we were inside of here, right? Let's do a. So we could, for example, say that somefunc, right? It's already been declared. We could overwrite the value. Right? We can say somefunc is now something cool, even though it started out as something also cool originally. And then the other cool thing, right? So if I do console.log somefunc, right? Somefunc is something cool, and if I call it my variable checker, right? It's going to grab that from the top scope. Right? It's going to say some func equals something cool because it is inherited. It's pulled down some func from the global state, from the global scope. So things inside of a scope can see things inside the scope above it. Like if you think of this is all global scope, this is all global scope, then this creates a brand new scope and it only exists when I run it. If we've not defined some func in here, then it's going to say, well, does the scope above me have this? And the answer is yes, in this case it does. But if I was to define, let some func equal, let's just call this function console.log high. Okay. Right, if I run this now, right, it's displaying our function. But if I look at some func from the global scope, right, because the global scope in this case is really the window object, window some func. So the window object only gets things that are defined with a variable, var. So if I do var some other thing equals high. So we were talking about the window object being kind of weird, some other thing, right? Whenever we declare something with var, it is put in the window object so that it becomes global for everyone. Whereas let intentionally encapsulates it inside of the script that it belongs in. Okay, so there's a script level scope as well. The window object does not have a sum func. Right? It's undefined here. Yeah?
So the window doesn't work with let, but it works with var. Can you explain that again?
It's complicated. I don't actually know all of the details of what's going on behind the scenes. There might be for the first 25 years of JavaScript, the only way we could declare variables was with var. We'd say var whatever equals hello, right? Every variable declared that way was global, was available everywhere, right? Because these are all hoisted to the global scope. And the global scope in this case is the window object. So when I type window and I say window.whatever, right? This var keyword is putting this variable as a property in window. This is the utmost, the greatest global scope that exists, is the window. It speaks to this entire browser. If I open a brand new tab, right? This is a brand new window object, a brand new scope. Window.whatever does not exist over here, but it does exist in here. Right? Think of the window object as this is my browser, this is my page. And then inside the window object, right? Window.document, right? That's the other main object we've been using pretty often, right? And we shorthand it by just saying document.getElementById, right? Or document.whatever. That all exists, right? That all exists really in the window object. Window.document.getElementById is the exact same as document.getElementById. So everything that is declared globally, is declared in the window scope, is a super global variable, and that's how all of our APIs are the date object, right? Is really window.date, right? Window.array, right? That's an array. So I could do var r equals new window.array, and r is now just an empty array. All of these things that we've been learning about, all these functions and methods and cool little JavaScript things, they all exist inside of the window object, and you can just scroll on down here and take a look at what all is available. Right? Animation controllers, audio functions that if you're ever going to build a chat app or something that needs to be able to make noises, right? You might have to use some of these methods, some of these functions. All of our CSS rules, there's date, there's a data view. It's a huge object. Anything the browser can do, there is a JavaScript class or a JavaScript function that we can grab from the window object.
With var, but then it doesn't.
var is how we declare a variable.
Okay.
So the window object has all of this stuff on it already for us. All of the stuff we've been learning already exists in window. And when we declare a variable with var, and I say var, her name equals Selena, right? I'm saying with var create a variable, create a property in window, her name. Okay. When I make it with let, when I say let my name equals Eric, right? Let his name equals Eric, right? His name does not exist in window. Window dot his name, undefined, because that is at a higher scope than our current global scope for this this session even is.
Okay, so let is like this, and then var is more kind of like this. Maybe.
I don't know what your arms mean, but let's go with yes.
Okay.
Var is like a bazooka. When you say, I want to create a variable and use var, the variable will exist. You'll be able to use it from all over the place.
Okay.
When you create a variable with let, you're saying, I just want this variable to exist in the current scope I'm in, whether that means you're inside of a file, or you're inside of a function, or you're inside of an if block. It's going to always go to the smallest possible space it can live in.
Okay, I get it now.
Mm-hmm.
Thank you.
Yeah, you're welcome. Good question. Loops. Let's save loops for tomorrow. Cool. That's a good stopping point for today. Tomorrow we're going to go over loops and iteration and some styles in scripting, and we'll probably spend most of tomorrow actually trying to build something with JavaScript, working on some exercises and practicing. It's been a while since we've gotten to really code as a part of the class, so we'll get back to that tomorrow. It's 6:37. Let's see. Any questions over anything we've gone over today? Go ahead, Eric.
I just wanted to know if anybody looked at my JavaScript memes explained page.
Yeah, I thought it was pretty funny. Anyone else have a chance to look at it that he pasted yesterday? Yeah. You can send it again. You're probably better off sending it in Slack so that people can look at it after class. All the chat messages disappear once we leave. No questions about anything we went over today. You guys are all ready to go? Alright, well, we're going to do another quiz just to keep repetition going and to exercise our thinking muscles. Is that quiz ready to go, Selena? Ready to go-ish? Alright, let's, it's 6:40 right now. Let's just take a quick break. Maybe it's 6:05, 6:10, or 6:45, or 6:50. Let's do 6:50. Take a quick break. When you come back, we'll have a quiz. We can do it, and then we'll go over it together like we did last time. Okay? Recording. All right, cool. Everyone got your name right. Good job. Yeah, the code for and is 2 ampersands. This one was one that maybe threw some of you off. The numeric value for false is 0, right? 0. True is generally like a 1 is yes and a 0 is no. So false is always 0. But in JavaScript, they treat anything that's not 0 as true. Most of you got this right. What is printed to the console? What was printed to the console is the number 12, right? That's the 12th of the day. So the get date returns the day. Yep. And then we accepted pretty much all answers. But in general, just calling new date like that will give you the current date and time. What is the code for something to be important in CSS, right? Not important like that, or exclamation point important, as it's really is in CSS. Would these both need to be the same in order for it to return true? This or that, right? Two pipes is or. And if you recall, when we were learning about the Boolean logic, or is a if any of them are true, right? If any of them are true, it is true. So, would these both need to be true? No, just any one of those will be good enough. If you forget a break, then the script will run from the case where the criterion is met, and will run the cases after that, regardless if a criterion is met. And the answer there is true, right? Inside of a switch statement, inside of a switch, the code will run line by line until it reaches a break. Break will always break you out of a switch statement. When JavaScript reaches a break keyword, it breaks out of the switch block. The answer here is true. We just kind of talked about that. functions are defined as blocks of code we like to call later. Yeah, that's true. And then what at the end of a function name calls it, right? So a function name is the name of our function. It is always called with parentheses. We end our statements with a semicolon. So, most of the time we'll say something, parentheses, semicolon, but it is actually called when we include the parentheses. Okay? A dot is chaining calls or chaining statements, right? So if you've got an object, or if you've got an object that has a function in it, and that function returns another object with a function in it, you can chain them together and say document.getElementById.style .background color. That's chaining properties down that object chain. But functions are called when we include the parentheses. This one kind of tripped some of you up. You can only have one return in a function, and we even played with this as an example today. The answer is false, right? We can put return statements inside of if blocks in a function and say, hey, if you don't put in the right number of variables or you don't put in the right number of arguments, return false or return error, right? So the answer here is false. You can have as many returns as you want, but as soon as it hits a return, as soon as your execution reaches the return statement, it's kind of like the break statement, it leaves the function. Okay? Let will not let you overwrite some other overwrite other same name variables, right? So if you have let my name equals Eric, and then I try to say let my name equals Sally, it's going to throw a warning and say this is let has already been declared. So this is true. All of you did pretty well. There were no concepts that each of you found equally confusing. There was some mention around JavaScript dates being kind of wonky, and I agree with you. Thinking back to like why dates are the way they are is that in the 90s when JavaScript was being developed, most of the programming languages at that time had a very similar structure for dealing with and handling dates. And so JavaScript just followed that same principle from things like Perl. This even predates PHP at that time. But there are other JavaScript libraries that provide other APIs for dates. The date object built in is like the standard library for JavaScript, the formal date one. It's not that big of a mechanism, right? These are pretty much, if we go and look at our code from today, right? There's only like 10 functions in here, 15 functions that let you work with dates. You just have to memorize them and know what they do, or at the very least, right? As long as you're aware that I can come in here into a console and type new date, or new date dot, and start to see what all those functions are in here, right? Should be pretty easy to figure this out, right? There's a whole bunch of really cool complexity in here, like what is the UTC date, right? That is the Greenwich Mean Time date, right? So if it was, we're at -4 right now, right? We're on the 6th. If we waited, like an extra 30 minutes, then this would give us a different, right? So if we get date here, right? Get date here is 6, but if we get UTC date, right? This is telling us what the date is at the time zone, right? Or at GMT 0. So all of these functions, all these methods that exist in this object, you just have to learn how to use them. If you need a refresher on this, like W3 Schools is a good resource, right? All of these have examples in our documentation of how to use these things. We're just scratching the surface on all of the complexity of JavaScript in this course. We literally don't have time to go over each and every API endpoint. We're really just hoping to teach you how to learn these things on your own so that you can go read documentation and see, how do I use the audio interface? How do I use the camera interface? How do I save things to local storage, right? No programmer you're never expected to memorize everything. You just have to know how to figure out how to use it, how to read documentation, and how to apply it in your code. Nobody can remember everything there is to know about programming. It would be impossible. Unless you're, one of those savant type people that have photographic memories. But go ahead, Olivia.
So I hope this question doesn't take up too much time, but I understand what you're teaching, but then for JavaScript, but then I don't understand the purpose, like what it does really. Like, so when you do HTML, you see it happening, and then like CSS, you're saying something and then it happens. But I'm having a problem like with JavaScript understanding how that all ties together.
The short answer to your question is that for the next 5 weeks, we're gonna show why we use this, right?
Oh, okay.
Really starting tomorrow,
Okay.
because now that you've learned the basics of the language, we're gonna start applying it tomorrow. We're gonna, it's gonna start with me, where I'm gonna actually start. We're gonna think of an app. We're gonna start building it together, and this is all on the front end. So we're gonna make things functional on the front end. Then, when we get into the back end stuff, we're gonna continue to write JavaScript with the exact same language, the exact same syntax. But now we're going to be having JavaScript saved to databases for us, render pages for us, create templates, all kinds of really cool stuff that we can do once we get into the back end. But first we have to learn the syntax and learn, like, if I need to use an if block, how do I actually literally write an if block, right? Because we're going to use that
cool.
over and over
So,
and over again. Yep.
Yeah, that's just the next step, because I feel like I can, like you said, learning a new language, I can read it, but I can't speak it if someone talked to me about it. Okay.
That to me is like, so I've been talking to Selena for like 6 months about this. This is one of, I think, the failures of the traditional education system, is that they just teach you the theory. You don't spend any time in application. And so one of the things that boot camps are great at is that we're breezing through, and we can just barely scratch the surface at all of the things you can do in a language. And this is just one language. There's 100 more. But what we will spend a ton of time on is practice and repetition of actually building things that matter. Because each and every one of you, when you go and get your first or your second or your third jobs here, you're always going to be working on different, new, and unique products and problems. And so I can't teach you how to do the work you're going to do in your first job, because I don't know what you're going to do in your next job. But what I can teach you to do is, this is how you think about building programs, this is how you think about building applications, so that when you get to your new job, you know, like, I know structurally how to set up a program, how to set up some code. And so even if you're working in a completely different language, you can go like, how do I do control structures in PHP? How do I, does Drupal or does Joomla or does any of these other existing frameworks have a mechanism for creating templates on the back end? Like, the concepts we learn here will translate into Google searches for you in the future. Hopefully.
Okay, cool. Thank you.
Yeah, great question. Any other questions? Like this week, we took a steep, it's a steep learning curve here. We jumped from HTML and CSS, which you guys were starting to get the hang of, and we moved into a new programming language where not only that, I have to spend all week just talking to you about, like, these are things to be aware of before we can even go into, like, this is how we set up a program. Here's why we would choose to use a switch statement. Here's why we would use an if block. Here's what our functions are for, so that we can start to actually make real things that people will pay for. So this week is kind of the just listen week, and it gets more fun and interactive the more days we have under our belt, because the rest of the course is all JavaScript. Cool. All right, let's play Kahoot and close it out with that. We've got like, I don't know, 25-ish more minutes left. So open up your Kahoot, and this is a JavaScript one of stuff we've covered really just this week, and so this should be pretty fun. So Kahoot.it 9637302. Josh is in. Welcome aboard, Josh. I'm in. Sally Jenkins is in. Other Eric is in.
Sorry, where do I go again?
Kahoot.it, Kahoot.it. It's right here.
Okay.
And then you punch in that.
Oh, I found it.